M.Yogadharani, working as assistant professor in Department of Computer Science and Engineering at SNS College of Engineering. Today I am going to discuss VD method and dynamic programming in design and analysis of algorithm. Today's agenda is VD method, dynamic programming, and comparison between VD method and dynamic programming. What is tabulation? What is memoization? These are the topics I am going to discuss in this video. Before getting to the topic, DAA is a design and analysis of algorithm. This is the fundamental concept area for computer science, which deals with the creation and evaluation of algorithms, which are in a step-by-step procedure to solve a computational problem. So for the computational problem, these are the techniques to solve the computational problem. Some of the techniques are greedy method, dynamic programming, divide and conquer, and then backtracking, branches one. These are the techniques which are used in DA subject. In this video, I am going to explain greedy method. So in greedy method, we use a predefined procedure to solve a problem so that we get a optimal solution. Like Kruskal shortest path algorithm, always select shortest path vertices and continue relaxing vertices to the graph so that we can get a shortest path. That is the best solution in greedy method. Unlike in dynamic programming, we use a principle called principles of optimality. So in dynamic programming, for every programming there may be a many number of solutions are there. Among the solution, we pick only the feasible solution. Among the feasible solution, we pick the only one best solution. So principle of optimality is nothing but this is the problem. Problems solved by a sequence of decisions. So in dynamic programming, we use this principle only, that is a principle of optimality. This is nothing but sequence of decisions which are stored in a table method. The main difference between greedy method and dynamic programming are dynamic programming is a little bit time complexity compared with the greedy method. So in dynamic programming, there are two methods are adapt for others. First one is tabulation, and then second one is memoization. I am going to explain these two methods with an example, and you guys might be clear about explaining with the example. Guys must know about Fibonacci series, and the series are 0, 1, 1, 2, 3, 5, 8, and likewise. So this is the pseudocode for Fibonacci series. Int fib of int n, I take integer as n, and if n is less than equal to 1 means that's written n as it is, and this is the formula for the counting Fibonacci series, that is fib of n minus 2 plus fib of n minus 1, then return something, and function if 0, n is equal to 0, if it is 1, n is equal to 1, then fib of n minus 2 plus fib of n minus 1, which is n is greater than 1 if. So this is the function. Okay. First method is tabulation method. Before we get into the tabulation method, we just trace the pseudocode one. If I have to find f of 5 and then function here, first iterates here, okay. And then what is the function here? If n is greater than equal to 1, yes, my n is 5. Here n is equal to 5, clear. If n is greater than equal to 1, no, just get into the this line. Fib of n minus 2 one function and plus fib of n minus 1 is next function. So just trace the tree. F of n minus 2, 3, f of n minus 1, 4. And then further divided into subproblems like f of 1, f of 2, n minus 2, n minus 1. And this one is, if this function can be subdivided into further divisions are there? No, impossible. So here f of 0 and f of 1. Likewise also this side. F of 2, function of 3, and further subdivision f of 0, f of 1, Likewise here, f of 1 and f of 2. Likewise, I just erase this, f of 0 and f of 1. So for this, I have to calculate f of 5 for the Fibonacci series. This is the tracing tree for this pseudocode. So see here, f of 0, how many times are printing here? Recursive function f of 0 is recursively called for 3 times, and f of 1, 1, 2, 3, 4, 5 times. So instead of I calculating every time for this subfunction, once I calculating this f of 1, I just use this result for all the f of 1 which are called further times. So for this total time calculation is 15 times this one line is executed. So the time complexity is big O of 2 power n. This is the array. Index 0, 1, 2, 3, 3, 4 and 5. See here, I have to find out this f of 5 series. So for this I have to calculate from 0th index to 5th index. So initially I have n is equal to 1. If n is less than 1, it prints the n value. First one is 0, Fibonacci 0, and then it is to the increment. So f is equal to 1, then n is less than or equal to 1, yes it's true. So print the n value as 1, clear. Next 2 incremented. If n is equal to 2, less than or equal to 1, if it is no false, and then goes into this line. See here, iteration takes place. Here for f of 2, we already know about f of 0. Yes, it's 0 plus f of 1 is 1. So f of 0 plus f of 1 is 1. It's calculated. Then f of 3, already I know f of 1 is 1 and f of 2 is 1. So plus, so 2. Likewise, this side, okay. I have calculated how many times? This one time, this one time, this one time, this one time. Totally 4 times. And then here, I know this f of 2 I know. F of 2 is 1 and f of 3 is 2. 2 plus 1, 3. F of 4 is calculated. So 4 plus 1, 5 times. See here, f of 3 is 2 and f of 4 is 3. 3 plus 2 is 5 and 6. So for n is equal to 5 and this line may be calls from n plus 1 times. So the time complexity is big O of n. So this is the tabulation method. In this video, I will explain about what is memoization with example. Thank you. So this is the second method, that is memoization. In this type, consider this as the array. I have to find the f of 5, Fibonacci series 5, 0, 1, 2, 3, 4, 5. Okay. For this is the pseudocode. I write in the another method. See here, if n is less than or equal to 1, just return n. And in this pseudocode, I entered the f of 0th element, which is 0, and f of 1 is equal to 1. Just write here 0, 1. Okay. Then get into this for loop. For int I is equal to 2, I is less than or equal to n, I plus plus. For this, I have to using this formula. In case this is my I, and then this is I minus 1, I minus 2. By adding these two elements, I can get this element. So 0 plus 1, 1. Incremented I, here I minus 1, I minus 2. So adding these two numbers, I can get 2. And then I incremented here. Adding these two numbers, I can get the 4th element. Adding these two elements, I can get the 5th element. So for f of 5, I counted this loop in 5 times only. So here the order of time complexity order of n. So this is the more effective than the tabulation method. So I just give away for this topic today's handle here. And in this video, I explain what is the purpose we study DAA, and what is a greedy method, and what is dynamic programming. How and comparatively, what is dynamic method and dynamic programming, and what are the methods used in dynamic programming like tabulation, memoization. I explain example with the Fibonacci series. I catch you in another video. Bye.